This content is produced by Pass the CSLB, an independent audio-first study companion for busy California B general candidates. I build these lessons from official CSLB study guide topics and reputable source-backed California materials, so you can study on the go. This is exam prep reinforcement, not legal, professional, engineering, or job-specific advice. Exam content is set by PSI and the CSLB and may change, so always verify current requirements against official CSLB materials. No exam outcome is guaranteed. Now let's get into it. A structural connector is not just the piece of metal you can see. I want you to treat the connector, the wood, every fastener, and the manufacturer's instructions as one tested system. Change one part for convenience, and the published capacity may no longer apply. That is the central field decision in this lesson. A hanger with the wrong nails can look finished. A strap with two empty holes can look close. A shiny screw can look stronger than a nail. None of those appearances proves that the connection matches the tested installation. The supervisor's job is to compare what is installed with what was specified before the work is concealed. The cause and effect is direct. The connector transfers force into the framing through its fasteners. The fasteners carry that force through their shanks, their embedment, their number, and their position. If the shank is thinner, the fastener has less cross-sectional area available to resist shear. If the fastener is too short, it may not reach the member that is supposed to receive the load. If holes are left empty, the connector has fewer load transfer points than the tested configuration. If the metal is altered, the installed shape no longer matches the evaluated product. I use a simple memory connection: hardware, holes, and handbook. Hardware means the correct connector. Holes means the required fasteners are present in the required locations. Handbook means the manufacturer instructions and evaluation report control the installation. That phrase is not a substitute for reading the instructions. It is a fast field reminder to stop a casual substitution before it becomes concealed rework. The published Contractor State License Board study outline identifies seismic hardware requirements and installation as testable material within framing and structural components. I do not need to predict a particular question to tell you why this matters. A general B contractor is expected to recognize whether structural work is coordinated, installable, and ready for inspection. I want you to picture a connector package arriving on the job. The metal part, the approved fastener schedule, the wood thickness, the loading direction, and any limits on substitutions belong together. The connector alone does not carry a listed load. The listed assembly does. Manufacturer instructions and evaluation reports are especially important because prefabricated connectors are tested in defined configurations. The test does not prove the capacity of every nail that happens to fit the hole. It supports the listed connector with the listed fastener type, diameter, length, quantity, and installation pattern. That is why convenience is a poor substitution standard. A crew may have a coil nailer already loaded. A shorter connector nail may be easier to drive in a tight bay. A deck screw may feel aggressive because of its threads. The correct question is not whether the fastener is easy to install or looks substantial. The correct question is whether the manufacturer permits it for that connector, that hole, that wood condition, and that exposure. Suppose a crew installs a row of hangers late in the day and skips the holes that are awkward to reach. The immediate condition is a connector with fewer fasteners than the evaluated configuration. The practical consequence is that the published load value cannot simply be assumed. The supervision choice is to stop, verify the required hole pattern, and correct the installation before the floor or wall is closed. The first inspection habit I want you to build is an exact fastener match. Check quantity, type, diameter, length, and location. Those 5 checks catch most of the shortcuts described in the research report. Looking at this checklist, the order matters less than the completeness. Quantity asks whether every designated fastener location required by the instructions is filled. Type asks whether the connection uses the listed nail or a specifically approved structural connector screw. Diameter asks whether the shank matches the specification. Length asks whether the fastener reaches the intended receiving member. Location asks whether each fastener is in the correct hole and driven in the intended direction. Do not turn the word exact into a slogan that ignores the documents. The field rule is to follow the specific schedule that applies, not to invent a universal rule from the connector's appearance. Where the evaluation report designates the holes and fasteners needed for the selected capacity, that schedule controls. The same discipline applies to substitutions. A manufacturer-approved structural connector screw may be allowed in a listed schedule. A standard wood screw, deck screw, or drywall screw is not automatically equivalent just because it fits. The research report supports a hard boundary. Do not substitute fasteners or hardware based on convenience. I also want you to separate procurement approval from field appearance. A box that says galvanized, structural, or exterior is not enough by itself. The label, product data, evaluation report, plans, and instructions need to line up with the actual application. That is how I would supervise the decision before hundreds of identical connectors are installed. Now I want to clear up the penny-sized trap. A 10-penny common nail, a 10-penny box nail, and a 10-penny sinker can sound interchangeable because the penny designation is the same. They are not automatically interchangeable. The research report gives a useful comparison. A 10-penny common nail can have a shank diameter of 0.148 inch, while thinner 10-penny box or sinker nails may have shank diameters around 0.128 inch or 0.131 inch. The exact product data still controls, but the lesson is clear. The penny name alone does not confirm diameter. Here is the physical connection. Shear acts across the fastener shank. A thinner shank has less cross-sectional area. That does not let me calculate a connector's allowable load from diameter alone because the tested assembly and evaluation report control the rating. It does explain why a visually similar thinner nail is not a casual equivalent. On a busy framing job, nail heads can make this harder. Once the nail is driven, the supervisor may not have an easy view of its full length or shank. That is why control starts before installation. Verify the exact carton, keep incompatible fasteners out of the same work area, and confirm the tool is loaded with the approved product. After installation, use the head markings, packaging, and manufacturer guidance that are available for verification. Imagine a framer says, "It is still a 10-penny nail." I would answer, "Show me the diameter, length, and approved schedule." That response is respectful, fast, and tied to the actual requirement. It turns an argument about habit into a check against the evaluated system. Double-shear joist hangers make the length issue easy to understand because the angled fastener path has a specific job. In the example supported by the research report, the hanger schedule calls for a 0.148 inch by 3 inch nail into a 2 by carrying member. The full-length nail passes through the carried joist and embeds into the supporting header. That creates the intended double-shear load path through both wood members. A short 1 1/2 inch connector nail placed in that angled slot may enter the joist but fail to reach the header. It can fill the hole and still miss the work that hole was designed to perform. This is the central counterfactual. What happens if the nail never reaches the supporting member? The hanger cannot transfer load through that fastener in the tested manner. The research report states that substituting the shorter nail requires a load capacity reduction. Any reduced capacity use has to come from the manufacturer data. The installer does not get to estimate the reduction by feel. Suppose a positive placement nailer is loaded with short connector nails because the crew is also filling face holes. The tool may place those nails neatly into angled slots. Neat placement does not cure insufficient length. The supervision decision is to verify the schedule for each hole group before production begins, not after an inspector notices a repeated pattern. I want you to remember the phrase reach before rating. Before relying on a published rating, confirm that the specified fastener reaches the member named in the installation. That is especially useful with angled slots, concealed support members, and any connection where a short fastener can look complete from the exposed face. Corrosion protection is the other half of the system. The 2025 California Building Code Section 2304.10.6 and the 2025 California Residential Code Section R317.3 address fasteners and connectors in contact with preservative-treated or fire-retardant treated wood. The source-backed material identifies hot-dipped zinc-coated galvanized steel, stainless steel, silicon bronze, and copper as permitted material categories for this contact condition. For zinc-coated fasteners, the coating weight must conform to the ASTM A153 minimums. Stainless steel-driven fasteners must meet the material requirements of ASTM F1667. The practical reason is compatibility. Treated wood contains chemicals that can be aggressive toward unprotected steel, especially when moisture is present. Corrosion can progress along the buried shank where a quick surface glance does not reveal the loss. The immediate condition is not always a dramatic red stain at the nail head. The hidden section of the fastener can be the part losing metal. That is why the word galvanized needs a follow-up question. Hot-dipped galvanizing and electrogalvanizing are not the same coating process or coating thickness. The research report specifically warns that electrogalvanized fasteners are not acceptable in chemically treated wood or exposed exterior conditions unless an evaluation report explicitly verifies that fastener for the specific environment. I would not accept a crew member saying, "The box says zinc." I would check the listed coating, the applicable standard, the manufacturer's environmental guidance, and the wood treatment. This is not paperwork for its own sake. It is a material compatibility check that protects a connection after it disappears behind finishes or underdecking. Keep dissimilar metal compatibility in mind as well. The safe choice is not to mix connector metals and fastener metals casually. Follow the connector manufacturer's corrosion guidance for the complete assembly and the actual exposure. The California code categories establish the baseline, while the listed product information identifies the compatible configuration. Field modification is another place where a capable carpenter can accidentally step outside the evaluated system. The division of the state architect interpretation identified in the research report states that prefabricated wood connectors must not be field bent, cut, or altered unless the manufacturer's instructions and the corresponding evaluation report specifically permit that modification. The important distinction is between fitting the framing to the approved connector detail and reshaping the connector to fit an improvised condition. If a pipe blocking conflict, skewed member, or misplaced opening interferes with the hardware, hammering a flange flat is not a design solution. Cutting off a leg is not a minor trim. Drilling a new hole is not automatically harmless. Consider a hypothetical shear wall condition where a service line conflicts with a hold-down strap. The tempting shortcut is to bend the strap around the obstruction. The immediate result is a connector shape that differs from the evaluated product, and the bend can also damage the protective coating. The next decision is not to hide the bend. It is to stop, coordinate the conflict, and obtain a permitted detail through the proper project authority and manufacturer information. Approved alternatives may exist: a different listed connector, an approved structural connector screw, or a revised engineered detail may solve the problem. The general B boundary is that the field crew does not create the approval by making the alteration. The supporting documents must authorize the configuration. This is where sequencing saves money. Review hardware conflicts before rough plumbing, electrical work, or close-in creates a forced choice. Confirm the connector model and fastener schedule during layout. Inspect before concealment. A few minutes of coordination can prevent removal of finished work and replacement of damaged hardware. I use a 3-pass inspection for connector work. The first pass happens before installation. I verify the connector model, the plans or approved detail, the manufacturer instructions, the evaluation report when applicable, the fastener package, and the exposure condition. The second pass happens during a small initial installation. I check orientation, designated hole groups, nail angle, fastener type, and certi whether the tool is placing the correct fastener without altering the connector. I would rather correct one sample bay than discover the same mistake across an entire floor. The third pass happens before concealment. I look for missing designated fasteners, wrong heads, short nails and angled slots, unapproved screws, bent or cut hardware, coating damage, and contact with treated wood using an unverified finish. I also preserve the package labels and product information needed to explain what was installed. Inspection readiness is not about making the work look good for one visit. It is about being able to trace the installed condition back to the approved system. When the connector, fastener, substrate, and instructions agree, the inspection conversation is straightforward. When they do not agree, paint, caulk, and confidence do not create compliance. A useful job site question is, what document allows this exact choice? That question works for a fastener substitution, a field bend, a reduced capacity nail schedule, or a corrosion coating. The answer should point to the approved plans, manufacturer instructions, evaluation report, or other controlling project document. If the answer is only, "I have always done it this way," the work needs verification before it continues. I want to close the lesson with 4 connected checks. First, match the fastener quantity, type, diameter, length, and location to the applicable schedule. Second, remember that a penny designation does not prove shank diameter. Third, use corrosion-resistant materials and coatings that are actually approved for treated wood and the exposure. Fourth, do not bend, cut, drill, flatten, or substitute structural hardware unless the controlling instructions specifically permit it. The single idea tying all 4 together is system, not part. The metal connector is only one part of a tested load path. The exact fasteners transfer the force. The wood receives it. The corrosion protection preserves the connection. The instructions define the configuration that earned the published capacity. Before you leave a connector inspection, ask yourself 3 questions. Does every required fastener match? Does every fastener reach and resist in the way the schedule expects? Does the complete assembly match the approved material and installation instructions? Those questions keep the focus on evidence instead of appearance. There is an audio practice quiz for this specific episode on connector fasteners, corrosion protection, and manufacturer instructions. I made it audio-based with the questions read aloud and your answer selected by tapping, because I know you may be studying while driving, working, or moving between jobs. Go to the description below this video. You will see a link that says Pass the CSLB. Tap it. It will take you straight there. Comment below with any questions about anything I covered. Subscribe so I can help you stay on track through every episode until you get your license. I am rooting for you, and I want the next connector you inspect to feel less like a guessing game and more like a system you know how to verify.